In this tutorial, we are going to quantify the forces in a strip of a funicular vault. So it's going to be a 1 foot wide strip. And then we will quantify the stresses, and they should be comically low if you do everything correctly. So the first thing is we need the span of our funicular vault. It doesn't matter what that is. We can change that. I'm going to make it 75 feet. The rise of the strip, it doesn't matter what it is. I'm going to make it 20.5 feet. This should reflect your project that you're working on in paper, your prototype studies that you've been modeling. And then we will drop down the left point. Remember, if it's a Cartesian point, you have to start with a capital letter, and that will be at 0, 0. And the right, oops, I made a mistake there. The left Cartesian coordinate is left parenthesis 0, 0. And the right Cartesian coordinate, capital R, will be left parenthesis span 0. The vertical axis, the vertical component of that doesn't have to be 0. It could be 5 feet up or 10 feet up. It doesn't really matter. It depends on your project, right? But right now it's landing at the same elevation as the left. And then the crown, which is the highest point, I'm going to put that right smack dab in the middle between left and right. Doesn't have to be that way. It could be a little bit off center, span over 2 here. And the vertical, the Y component will be rise. And I will show these labels by just saying show label, show label, show label. And now I want to calculate the weight of this segment. It's a 1 foot wide segment. So I'm going to say width is 1. That'll be feet. The thickness of the shell, the thick, is going to be, let's say it's 2 or 3 inches. I'm going to say 2.5 inches. But GeoGebra doesn't recognize units, so we're just going to have to make sure that that's feet. So divide by 12. The easiest way to draw the semicircle here is on this drop down under the circles and go for circumcircular arc, a cool word here. And if you don't know how these work, you can always hold your mouse over and it says select 3 points on the arc. So it's pretty obvious, left, crown, and right. And I have a circumcircular arc. Here's the definition of it. If you hit the FX button here, you can actually get the value. And notice now this is a conic in GeoGebra, and the length of that conic is 89.15 feet. I don't have to type in 89.15. I could just type in the letter C because GeoGebra assigned that conic to be C. So the volume of my strip is going to be C times the thickness, and you could use a space or you could use a star, doesn't matter, times the width. And that's my volume, and that's in cubic feet. And then the weight of my strip will be that volume. So it's equal, that will be volume times 150 pounds per cubic foot for normal weight concrete. So I have 2,785 pounds of concrete. Now on my force diagram, I don't want to draw a whole bunch of little segments because I have to discretize this into a series of point loads. It's a uniform load. I'm going to choose 8 because it's really easy to get 8, and I'll show you how to get 8 right away. So we're going to create the force diagram by doing parallel lines, drop it over here, and I'm not going to draw 8 little circles. I'm going to draw one big circle. The radius will be the weight of cores divided by the force scale because that's thousands of pounds and I want it to fit on this page. So I need to put a slider in here, and that slider will be force scale. And it doesn't matter what you put in for min and max. I'm going to put in 1 to 500. Could always change that later. And now I'm going to create a circle like we did before under the circle icon. Here's the center of the circle, and the radius now will be weight divided by force scale. And now I need 6 o'clock as we did before. I'm going to be careful and find 6 o'clock. Boom, I think I got it. I'm going to hide this. I'm going to hide that. In fact, I'm going to hide the grid too, so things are a little bit cleaner. And I'm going to hide the axis. I don't need that. So now I have a nice clean screen, and I want to divide this into 8 pieces. And it's really nice the way that you could do this. You could just find the midpoint under the point icon and just say, hey, I have 2 points. Where's the midpoint? And repeat that over and over. I'm going to change my forescale because I'm a little tight here. And now find the midpoints once again. So this is way faster than drawing 8 circles. It's nice because they're all the same. In our first tutorial, we had different loads, so we had to have different size circles. Now I want to discretize this strip into 8 point loads, and I will use the discretize, or the midpoint button again, sorry, between the left and the right. And I'm going to do that a couple times here. Not just a couple, but I'm going to do it 8 to get 8 segments. Okay, now we're nicely done. Now the next step is just a little tricky. I have a load and I want it to be right here at the centroid of that segment, and I want the next load to be right here at the centroid of that segment. It's like a uniformly distributed load on a beam. You smear it into one concentrated load at the centroid. So I want to find the centroid of these segments, which is obviously I will use the midpoint, but I don't want to make a mistake. So I'm going to change the icon in the point to make it a big red X so that I don't make a mistake. And that's a nice little trick here. So now I'm finding the centroids of these points by going back to the midpoint here. And there's my big red X. So it's unambiguous. I know exactly that that's where the load is going to go. And then I'll draw the vertical lines through these red X's and through the right also, because my funicular is going to end there, and then we'll stop and we'll do part 2 of the video then. So I'm going to turn my axes back on here, which is this little button here. I need vertical lines. So I have to go here. Oops, Control Z. Don't you wish that life had a Control Z? Here we go, and through the X, through the X. And then I will upload this video because I haven't made too many mistakes yet. Maybe I could keep going. I don't know. We'll see. Maybe I should keep going. I'm feeling lucky. Okay. I'm going to keep going. I'm going to draw my funicular, and it will hit these intersects through the centroid of the 8 segments. So I'm going to turn off this grid, and then I think you could see everything nice and clear here. I'm going to move my force scale just a little, my force diagram a little bit over. Now the next thing is, remember, you need to set a pole. We're going to put the pole on the left side here because we're drawing arches, not chains. And I'm going to make a segment, and a nice green dashed line is nice, I suppose, here. This is easy breezy. I don't think I'm going to mess this up. And the next part is that mesmerizing part where you draw the parallel lines of the segments of the funicular until it intersects the path of the load. Parallel line. And I'm going to start at the left edge, and I'm intersecting this with where the load path was. I'm going to hide this right now so that I don't get confused. And I will make a segment here. Now the second segment. Oops. And so on and so on. Maybe I will stop now because I just made a mistake.